Hi everybody, this is Bert Kammerer with Smack FPV, and today we're going to be doing a build on the sRacer 207 or sRacer 207. So first things first, let's just go over what comes in the kit. So when you get your frame, you're going to look forward to opening everything up and making sure everything's there, of course. So first thing, most important thing is your bottom plate. It's a 3mm plate with an upgrade available for a thicker plate. Although we really haven't had any issues with breaking this during crashes, and we've crashed it many times. So bottom plate, of course your top plate, this is what holds your battery and so forth. Make sure you set that aside. And then you're going to have different little bags with all kinds of different things. You're going to have some spacers of different lengths. You're going to have some hardware bag with like all different kinds of bolts, different size bolts, an assortment of plastic parts, basically plastic spacers and plastic nuts. And you're going to have an XT60 connector mount made out of aluminum, and your camera assembly, your FPV camera assembly, which includes a couple of metal brackets and a carbon fiber plate and some screws and nuts and bolts. And then last but not least, you're going to get a PDB. PDB stands for Power Distribution Board. If you make reference to the video that we did where we recommend different equipment, you know that there's lots of different options for using a different PDB that has built-in features or whatever. But for the purposes of this build video, we're going to use this PDB since it comes with the frame itself. So that's it for the actual frame. Then you're going to need a bunch of electronics. So we'll start with first things first, motor. I chose to use the X-Nova. These are the 2204-2600 series, very high kV motors. Again, make reference to the video where we recommend electronics. There's lots of different kinds of motors that you can run. So you're going to need your motors. Of course, ESCs. In this case, I'm running the DYS BLHeli compatible 30 amp ESCs. These are also known as the XM30s. The reason why I'm using 30 amps and not 20 amp ESCs is because I'm running a very high kV motor. Again, I know I'm being redundant, but make reference to the video where we basically recommend equipment. I'm using 30 amp because I'm using high kV motor, so I want as much, I guess you could say, headroom as I can have on my ESCs. So motor and ESC. Up next, of course, I already showed it, but your power distribution board. And again, you can use an aftermarket one. There's lots of them out there. There's some power distribution boards that have OSD feature, which means you can watch live data on your goggles, like battery voltage and current and milliamp consumption and whatever. But for the purposes of this video, again, we're going to use what comes with the frame itself. So we'll use the basic PDB. Now, there's something important to know about this. If you're going to use the PDB that comes with the frame, you're going to need some kind of voltage regulation for your board. So if you go, there's some boards out there that have built-in regulators, like the Lux board, for example. So in that case, you don't need a regulator. But if you use any other kind of board, like a NAZE or a F3 board or anything like that, you're going to need to regulate the voltage because the board can only take 5 volts. And if you're running a 3S pack, you're running 12 plus volts. If you're running a 4S pack, you're running 14 plus volts or 16 plus volts. Make sure you get a regulator. So what we've done is we've designed this board around using a regulator called a Polalu, which is shown here. This is a 5 volt regulator. It's 500 milliamps. It's called Polalu. It's available from the Polalu website, POLOLU.com. This is part number 2843. Basically, this will solder into this board and will take care of regulating voltage to your main flight control board. Once again, that board can only take 5 volts. So it is important that you get a regulator like this. Again, you can buy a different PDB that is upgraded, that has a built-in regulator, so you don't have to do any of the soldering or whatever, but we're going to use, again, the board that comes with the frame. So we will solder this to this board. Another thing you might want to consider using is another Polalu, another regulator. This one here is, again, also available from the same POLOLU.com website. This is part number 2845. This is a 9 volt regulator. And we're going to solder that to the PDB as well. And the reason for that is we're going to regulate the voltage that goes to your video transmitter. And That is not a requirement. You don't have to do that. But we found throughout testing that if you regulate voltage to your video transmitter, you can make your video transmitter last a lot longer. And the reason being is as you're flying and you're feeding throttle and elevator and aileron and everything else, there's lots of voltage drops, there's current spikes, and basically that's not really good for the video transmitter. So if you use a regulator like this, then now you're regulating the voltage down to either 9 volts, this is a 9 volt one, or you can also get a 12 volt. And by regulating the voltage, your video transmitter will be happier because it'll get a constant voltage regardless of what happens, you know, with your throttle inputs and ESC and everything else. Again, you can use a 9 or a 12 volt. I choose to use a 9 because that regulates the voltage way down. So if I use a 3-cell LiPo, which is 12.4 volts fully charged, I can, 12.6 correction, I can regulate down to 9. If I used a 12 volt one, I really wouldn't be too safe using a 3-cell LiPo because since the LiPo is already at 12 volts, regulating down to 12 doesn't really regulate much. So we recommend a 9 volt for that. But again, it's optional, it's just highly recommended. So up next, you're going to need an XT60 connector. This is, of course, for your battery. You can buy that from any local hobby shop. You're going to need a couple of these. Basically, just buy a couple of servo extensions and then cut them. You need the male end with the wire, and these are going to be used to connect your board to your power distribution board, and then to connect your receiver to your board. So you need a couple of these wires right here with the connectors in the end. Then you're going to need your actual control board. For this build, I chose to use the F3 from Foxier. Very inexpensive, $20 US. You can't go wrong with that. Again, make reference to the recommended equipment video so you can see all the different boards that we've tested and we've tried and we know that work well. So you need your board, and then you need your FPV equipment. So FPV equipment, you know, we'll start with first things first. You'll need a transmitter, video transmitter, also known as VTX. We recommend this particular style. I believe it's a, they call it a 582 or whatever. It's made by a lot of different companies. Basically the same thing with different names. This is the Pyro drone version. There's the FXT, I believe, version. There's the Lumineer. There's all kinds of different ones. I believe Foxier makes one that has the same form factor. So the important thing is that you get a transmitter that has this form factor, because our frame was designed to accept this video transmitter perfectly. So like we cut the frame to where it would fit nicely so you can crash and you don't have to worry about breaking it or having to reinstall it or whatever. So video transmitter, pick anything from 25 milliwatts all the way up to 600 milliwatts. I use a 200 because I feel it's a good compromise. Allows me to fly with a bunch of other people without interrupting their signal, but it's not but it's strong enough to where I can go relatively far and still get a good image. Then you need FPV camera. It needs to be a case camera. These cameras are known as an HS1177 type camera. This is the Pyro drone version of the camera. I believe Sony makes one, or it's a Sony compatible. I don't know what the deal is there, but I think Lumineer makes one. There's one made by Foxier. They all look the same. They all perform the same. They're all good cameras. They come in a case. Again, our frame is designed around this case and this type of camera, so you need that camera. There's a new camera coming out to the market as of the making of this video called a Run Cam. You can run those too, but I chose to use that one. And then of course you need an antenna. I chose to use the Triumph Triumph antenna. It's a really nice antenna. Works really well. Takes a lot of beating. It's from Team Black Sheep. Excuse me. Then you need a receiver. I fly Jetty transmitters, so I'm going to use, of course, a Jetty receiver. If you're Futaba, of course, you need a Futaba receiver. Spectrum, you would need a Spectrum satellite, and so forth. Then you're going to need a battery. So I'm going to fly this on a 4-cell battery, but I choose to use a 3-cell for my setup. And the reason for that is when you spool up the motors during setup, setting up your ESCs and stuff, with a 3-cell battery, you can go to full throttle for a few seconds and not blow anything up. With a 4-cell battery, when you're doing setup, you got to be careful not to hold full throttle without the props on the motors, because you could burn the motor. So I just use a 3-cell for the setup. And then last but not least, you need your props. I'm going with the dowel props. These are the blunt nose 3-bladed props. They're 5-inch, of course. T5045 is the model. So that covers it for the electronics that you need. Then last but not least, you're gonna need a lot of tools. Not a lot, but quite an amount. So first most important thing for tools is you need a good soldering iron. So I got a Track Power is the brand soldering iron here. It allows me to go to like 1,000 degrees, which I'm not going to go that high for small electronics, but make sure you have a good soldering iron with a good tip. That's very important. You want a relatively small tip so you can solder small electronics. You don't want a really big tip. Stay away from that. So soldering iron, of course, you're going to need your solder, and I personally recommend like a 60-40 type solder. This is just a 60-40 Rosin core high grade solder, and relatively thin too. You don't want something too thick because you're going to be soldering very small electronics. Stay away from like silver type stuff. You want something that melts relatively quickly because you're working with small stuff. Flux pen is not required, but I highly recommend it. It makes your life way easier when you're soldering small components like the boards and the power distribution board and things like that. Let's see what else here. Main tools: cutters, scissors. You're gonna need a 1.5 driver, a 2 driver, and a 2.5 millimeter driver. I choose to use Loctite always, although some people don't like it or don't use it on their quads. I do, because I think it keeps the quad together longer. You need like forceps or whatever you call these hemostats. Makes your life easier. Not required, but helps. And then a couple of drivers. I have a 5.5 for my camera assembly, which you really don't need. You can use a set of needle nose or pliers, but this is cleaner and better to use on nuts. And then an 8mm driver here, or it's not a driver, but an actual like tool for the props, removing and installing props and so forth. You might want to consider getting some black electrical tape. You might not need it, but it doesn't hurt. We're working with electrical stuff, so it doesn't hurt to have it. Definitely gonna need some double-sided tape. This is made by 3M, widely available, super nice because you can peel it off and it doesn't leave any residue. Let's see what else. You're gonna need some wires. You can use either 12 gauge or 14 gauge wire, and this is to solder your XT60 battery connector to your main power distribution board. So you need a little bit of wire. You're gonna need some zip ties, tiny little zip ties. You're definitely gonna need those. You're gonna need an assortment of heat shrink, which you're gonna need to like heat shrink wires as you solder things together and whatever. Let's see what else we got here. Velcro, self-adhesive for your batteries and stuff like that. I always carry alcohol with me so I can clean things up and get rid of the mess. And have something handy to clean the tip on your soldering iron. You want to make sure you always keep a clean tip. I also have these holding hands, I guess they call them, to help me solder some things. Not a requirement, but it does help. Also something that is not required, but it does help a lot, is a multimeter. So basically you can get this from any local hardware store for like very little money. This is a more high-end one, but you don't need a sophisticated one. The goal for this is, as you finish soldering your power distribution board and everything's all ready to go, if you're working with very small pieces of electronics, so if you overlap a tap with solder or something, you create a short. When you plug your battery in, you're going to blow things up. So it's great to have one of these so you can check for continuity and make sure that you didn't screw up on your soldering work. So multimeter is of big help. Again, not a requirement, but it's recommended. And then one thing that is required is some kind of laptop device. This is a tablet, so it'll work fine. It's running Windows. Laptop, tablet, whatever it is you have that you can run Windows programs works, and you're gonna need this so that you can configure your ESCs, your speed controllers, and so that you can set up, tune, and configure your flight control for everything that has to do with setup to your gains on your actual flight control PIDs to your rates on aileron, yaw, and whatever. So I think that covers the list of tools that you're going to need for this build. Okay, so the first part that I recommend doing when you start building your quad is to pre-solder everything that can be pre-soldered. So preparing your PDB, your power distribution board, preparing your main flight control board, and doing all those things and getting them out of the way. so that as you start building the actual quad itself, like some of the things are already pre-done, so you don't have to like go back to soldering things while you're trying to get things accomplished. On our PDB right here, we have to prepare it, meaning we have to pre-solder the regulators to it. And as I explained before, you can choose to either go with a single regulator, 5 volt for your flight control board. You can choose to go with 2 regulators, a 5 volt and a 9 or 12 volt one for your video transmitter. Or you can choose to not go with any regulators if you have a board that can regulate its own voltage down to 5 volts. I'm going to use both regulators, 2 Polalus here, a 5 volt for my flight control board since I'm using an F3 board, and a 9 volt for my VTX. That way I'll make sure that everything runs smoothly, and especially my video transmitter will be happy getting 9 volt supply of constant voltage. So if you look at the PDB right here, you will notice that on our PDB we have 2 little center sections right here. One says Polalu aux 1 right there, and one says Polalu aux 2 right there. And if you pay close attention to this, you're going to see how there's all these 4 tiny little holes are labeled. You have a V out, a ground, a V1, and I believe that says a 5. That's the SHDN or whatever that means. So it's actually not that hard. What you need to do is we're going to open a Polalu here and show you that the Polalu itself has the exact same labeling. This is the 9 volt, the one I'm opening right now. Now your Polalu will come with these 2 pins, sets of pins. You have a 90-degree angle pin, which you're not going to need. I don't know if the camera can get it right there. And then you have a straight pin like that. So you're going to use the straight pin. And if you look at the Polalu, the back of the Polalu has the exact same labeling that your PDB has. You have a V out, you have a ground, you have a VIN, and then you have a the last but not least that SHDN input. So all you have to worry about is that the Polalu labeling matches the labeling on the board itself. That's the important thing here. So this will be assembled like this. You're gonna put these pins through here. You're gonna solder these pins to the Polalu like that. And once that is soldered, then you're gonna solder these to the board like that. So this is how the board will end up. Of course, you solder that, then you'll cut these pins down flush with the board, and the board will end up looking just like that. And you'll have one regulator here, one regulator there. Then the output for those regulators is actually going to be to the side of the regulators, and you're going to basically see on the actual board itself how you're going to have the output for one right there and the output for the other one over there. It says aux 2 right there, that's the positive, and it says the aux 1 right over there. So we'll get to that later, but what I'm going to do first is I'm going to solder this Polalus together. And I already have one set up here on my helping hands. And as you can see here, I have the helping hands basically helping me line up those pins with the actual board. And you got to make sure that you're at a perfect 90-degree angle there so that it's not bent when it goes into your PDB. So the soldering for this is no different than the soldering for your flight control board or any small electronics. I'm pre-warming my soldering iron to about between 600 and 700 degrees. And what I have done ahead of time is I have used the flux pen that I have showed you guys before, and I have basically added a little bit of the flux to those pins to make my life easier in soldering. But I'm going to add some more, just a little bit right there. And then I'm going to use a relatively small tip. And I'm going to apply a very tiny little bit of solder to each one of those pins and make sure that it's flowing and soldering the pins down to the board itself. And I don't know if the camera can get it, but my overhead camera, but you can see how easy it is to solder when you use that flux pen. It allows the solder to just flow through your electrical connection, making it way easier. So I think I'm missing a little bit of solder here. So let's go ahead and get that. Make sure it's all nice and neat and everything is soldered and I have no cold joints. And I think I got it. So after that's done, then I'm going to use my helping hands to basically hold the board to hold the palalu to the board. And I'm going to double check one more time that I'm doing this correctly. So V out is going to match V out, SHDN is going to match SSDN, and I have VIN and ground. They're all matching perfectly. The labels on the palalu are matching the labels on the board. Now for this, I'm not going to probably use the helping hands. For this side, I'm probably just going to use like, see if I can use the hemostats or the forceps like that, just to keep it straight. The goal here is just to keep it straight, and that's pretty straight right there. So let's see if I can get that very first one right there. Get some flux going in there once again. It does make things way easier. I'm going to use the helping hands just to put a little bit of weight there so it doesn't flip on me. And then I'm going to put a little bit of solder right there. Once I get a pin soldered, just one or two pins, then I can let go of the forceps and the board will stay put, so I can do this much easier. Alright, I think I got two soldered. So now I can remove the forceps and hopefully it'll be in place, and it is. And if you can see on my close-up camera, I got a pretty close straight angle there. It's not perfect. I don't think it'll ever be, but it's really close. So then I proceed to solder the last two pins, one there. And soldering is a science, so if you guys are not comfortable soldering very small electronics like these, it is always recommended that you find a friend that can solder. Or another thing that you can do is a lot of local hobby shops nowadays have really good solderers, and you know, it would be probably wise to make a quick trip to a local hobby shop and say, hey, can you help me like solder and teach me how to do it? And I mean, it's really not that difficult. It's just going to take you a little bit of practice, but once you've done it a few times, you'll get proficient at it. So once that's done, and I take the cutters, and got to watch your eyes, and then I just cut those off, and that's it. So I have my first palalu soldered to this side. So that's it for this. What I'm going to do next off camera is I'm going to solder the other palalu to the other side of this board, and then my my PDB here will be ready to go pretty much. Okay, now that I have the two palalus, the two voltage regulators soldered to the power distribution board, then the next step we need to do here is we need to like pre-solder all these little tabs, or pads, I guess you could say. And the reason for that is it just makes your life a lot easier when it comes down to actually soldering the ESCs and the power wires to the power distribution board. So what we're going to do here is we're going to go ahead and take the flux pen, and we're going to apply a liberal amount of flux to all this stuff, just because it'll make our lives a lot easier. So once I have a lot of flux there, I clean my tip. And then basically what I'm doing here is I'm applying a little bit of solder to each one of these tabs. So if you look at the PDB, these are for your speed controllers. Also for your speed controllers, this is your main power wires. And then on the side, you basically have a ground and an auxiliary for one of the palalus, and then on the other side is opposite. You have the other auxiliary and the other ground for the other palalus. So those are the tabs I'm actually going to apply solder to. So I'm going to warm it up a little bit, apply a little bit of solder, right about like that, maybe a little more. That's good enough. So if you have our stock PDB, the one that ships with your frame, it should look like that once it's all ready to go. So then you're going to solder your board. Now, this board is already soldered. The reason I pre-soldered this before the video is because I figured that it would be redundant to show you guys how to solder this, since the same concept applies. The Polalus have the exact same pins that the board has. These boards come with pins that are in an L shape, so that when you plug your servo wires, you're plugging them like from the side, like so. But this board also comes with, and most boards do, straight up pins, so that you would plug in your servo wires from the top. I prefer the sideways pins because I like to plug it from the side, because it gives me a smaller form factor. It doesn't make the board as tall, so it allows me to run a smaller form factor on my quad, and we'll get to that later. But so anyway, you solder these pins to the board, and again, this is the F3 made by Foxier. Super self-explanatory. When you get the board, you'll get the pins. You'll see how the pins line up on the board on all these little slots. Just stick those pins on the slots and then solder them. And there's lots of solder joints right here. Literally 3 times 4, 5, 6, 7, 8. 3 times 8, 24 little solder joints you have got to do there. Again, if you use the flux pen, just flux it. Just make sure you're holding it either with the holding hands or with the forceps like this, and then just apply a tiny little bit of solder on all those, and make sure that you don't overlap the solder between more than one connection here, more than one pin, because then you're going to short the board. You're going to kill it. So that's very important. The other thing you do with your board is, if you look at the board, and this applies to all boards, whether it is this particular board, which is again is the F3 by Foxier, or the SBF3, or the Nays, or the Lux, you're gonna find an UART or UART, however you want to pronounce it, connection, and typically stay away from UART 1, because that's reserved for communication between the board's USB port and your computer to adjust the parameters on your flight control board itself. So Cleanflight, for example, which is the software that we're going to use to do the setup on this board, will probably more than likely communicate through UART 1. So you want to leave UART 1 alone. But you'll find UART 1, UART 3, UART 2, whatever it is, depending on your board. And when you find that, you're going to see that you have a few things labeled. You have a TX, you have an RX, then you have a 5V, and you have a ground or GRN, or whatever, however way they use, acronym they use. I used the RX for my orange wire, because RX is my serial connection, or in plain English, RX is my signal wire. That's what sends the signal from my receiver to my board. Then of course I put the red wire on 5V, which stands for 5 volts. That's my positive. And then I put the brown wire on my GRN or GND or whatever abbreviation they use for ground. So once again, brown is ground, red is 5V for 5 volts, and my orange right here is the RX, which is my signal wire. This is how you would solder any board if you're using S-Bus on Futaba, or UDI on, for example, Jeti, which is what I'm using, or Tyrannus or something like that. If you use Spectrum, you have to be careful, because you have to solder in a different location, because your Spectrum satellite cannot accept 5 volts. It can only take 3.3 volts max. So we're going to have another video later that you can watch where we talk about boards and how to configure your boards and things like that. But for the time being, this is how I solder mine, since I'm using a Jeti. So I'm going to the UDI Jeti connection, which uses the same port on your board, or the same location on your board as S-Bus. And once again, that's RX. And I picked UART 3 on this board. Again, we'll get more into detail about that. But basically, take your board, solder your male connection like I just did, and I just explained. Solder your pins right there, whether you choose to go with the straight up pins or the L-shaped pins. And basically, your board is pretty much ready. So with the board being ready and the PDB being ready, we're going to move on to the next part of the video, where I'm going to basically install the motors and the ESCs, and I'll also be installing the PDB to the frame. Alright, up next what we're going to do is we're going to install the PDB that we just finished, and we're going to install it right onto the frame, the bottom plate. After we install that, we're going to go ahead and install all 4 motors, install all 4 ESCs, and solder motors to the ESCs and the ESCs to the PDB. So make sure you have your bottom plate. Make sure you look for the long screws that come with your kit. There should be 4 of them. And some people will argue that why are you supplying metal screws when you should be supplying the plastic ones? Well, we've done a lot of testing, and we have found nothing wrong with using metal screws instead of plastic. The beauty of the metal screws is when you land on concrete or asphalt, the head of the screw doesn't break. If you have a plastic screw right here and you're landing all the time, and on asphalt or cement or concrete, over time you'll break the head of the screw, and then your board and your whole board and PDB stack will get loose. So we prefer the metal. If you want to use plastic, feel free to do so. You can get plastic screws from eBay, from Amazon, from an FPV supply store, a hobby shop, whatever. But anyway, what we're going to do is we're going to take these long screws, and as you can see here on your frame, you got these 4 bolts, these 4 holes that follow a perfect square pattern. So it's easier to distinguish the back from the front, because the back of the frame, of course, has the VTX mount. One thing that's also very important is I'm doing this in the correct way. You guys need to make sure that when you do this, these are going to fall off now. Oh, there we go. When you do this, that if you're looking at the frame from the back of the frame, you want to make sure that you do it in this fashion, because when you mount your VTX, your video transmitter, you want to make sure that you're mounting it like this. If you built the frame backwards, if you put the screws in the other direction, now your VTX is going in the wrong direction, and you don't ever want to put it like that, because this side of the VTX needs to be up, because that's where you have your button to change frequencies and your frequency control LEDs and all that stuff. What you want to do is you want to put nuts in there. So your kit has basically 8 plastic nuts and 8 plastic spacers. You can arrange this in any way, shape, or form as you would prefer. I like to put the plastic nuts first because it'll keep these bolts from moving all over the place as I'm trying to work on things. So you install the 4 nuts first, and the nuts will keep the bolts in place and will also create a little bit of spacing for your power distribution board. You want to have a little bit of spacing because your frame, your bottom plate on the frame is carbon fiber, of course, and your power distribution board right here has got circuitry right underneath it. You don't want this to be touching on carbon, so you want to create a little bit of spacing there, and these nuts will serve as a good spacer, and at the same time will hold these bolts together so that you can work easier, more efficiently. Okay, so once these nuts are on the bottom plate, then we'll put our PDB, power distribution board, on here, and then as you can see here, you have a clear spacing between your PDB and your bottom frame, which is very important. So once that's done, that's kind of staying there pretty good. So the next thing I'm going to do is I'm going to set all these spacers and nuts aside because we don't need them right this moment. And the next thing is I'm going to go ahead and install the motors here. So once again, I chose to use Xnova motors. These are 2204 2600 motors. They come in a nice package. These particular Xnova motors come with a separate hub, which means, you see the hub right here, you have to install this hub on the motor like so, with 4 separate screws. So what I'm going to do is, typically when I do my builds, is I take all 4 hubs and I install them on the motors all together, so I worry about like getting all my motors ready. But for the purposes of this video, to make things more efficient, I'm going to do one at a time. So I'm going to show you how I do one motor. And again, this pertains to Xnova. If you have a T motor, for example, or Cobra motor or any other kind of motor, you might not need to do it in this fashion because your motor might be ready to go and it might come with a shaft already installed. But again, on these X-Novas, you have to install these hubs. So I'm going to do one real quick just to show you. So 4 screws or 4 bolts per hub, and X-Nova is kind enough to send some extra ones. And as you can see here, I'm using a little bit of Loctite because I don't want that hub to back off. And generally you never have to change this hub. Once you install this hub and you fly this motor, I've gone through pretty severe crashes with the X-Novas and they take a lot of abuse. So I've yet to bend one of these hubs, believe it or not. So these will stay here pretty much forever, I guess you could say. So that's a really good thing. So one more to go. As you can see, I'm installing them and I'm not tightening them yet. And then now I'm going to go ahead and tighten them. And I'm going to have go in sort of a cross configuration. I'm not tightening like this, but like this. Okay. So now that this motor is ready, move this nut and washer aside. We don't need it until the very end. So now I'm going to go ahead and install this motor to the frame. A lot of motor manufacturers include the actual hardware, the bolts to install the motor to the frame, but if they don't worry about it. You will find those bolts along with your kit, and those are 3x6 bolts, 3x6 millimeter bolts, 4 per motor. I'm going to take 4 bolts right here, and I'm going to mount the motor to the frame. So you're going to mount the motor to the frame just in this fashion like this. Make sure that these wires are lined up the best you can. So if you look at the back of the frame as you line up the holes in the motor, just make sure your wires are also lined up with the frame arm itself. So for this we're going to need a 2mm, and once again I use Loctite. One thing to consider too is make sure that these bolts are going to work, or the bolts that you're using to mount your motor onto your frame are actually going to work, in the sense that you don't want to use very long bolts, because if you do so, you might your bolts might protrude on the inside of the motor can, and they might be rubbing up against your windings, your motor windings. So this distance, like technically the distance of the bolt, as you can see here, these bolts don't really get inside the motor very far, and that's what you want. You don't want a bolt that is just way too long up here and that can actually rub up against your windings, because that's going to hurt your motor and it might just totally kill your motor very quickly. That's pretty tight. Some people just choose to use 2 bolts per motor, and that's perfectly okay. You can do that if you prefer to use just 2 bolts. I like to use all 4 bolts. Some people like to save weight by using 2 bolts. I'm not that picky with the weight, so I'm good with that. So once the motor is in place, the next step is you find a location for your ESC. On the sRacer, if you can see here, there's 2 slots on the frame, and these slots are meant to where are designed so that you can run a zip tie around to hold your ESC in place. I'm going to put my ESC right about there. These ESCs are really large because, again, they're 30 amp ESCs. So what I need to do here is I need to cut these motor wires, and I kind of hate to do that, but it's really the only way to do it cleanly. So I'm going to leave just a little bit of slack, but figuring out that the ESC more than likely will install right about there, I need to keep these motor wires really short. So I cross my fingers, make sure I have a good location, and I'm cutting my motor wires right about there, just like that. So once the motor wires are cut, just double check, that's about right. So I'm going to solder the motor to the ESC, and then I'm going to solder the ESC wires to my PDB, my power distribution board. So I'm going to splice these motor wires real quick. Very little. You don't need to splice much out of them. And you got to be careful not to cut them as you're trying to splice them, because if you do, and the motor wire is already cut to length, now you're going to be in some serious trouble because you're going to have to shorten them even more and you might not have enough slack. So with them cut like that, I'm going to go ahead and get my flux pen, and I'm going to add a little bit of flux to those motor wires. I'm going to add a little bit of flux to the tabs in the ESC. Now an important note here, some ESCs already heat shrunk all the way through and through. So in order to access the motor tabs on the ESC, you have to cut the heat shrink on the ESC, remove the heat shrink, and then access the tabs that way, meaning the ESC already has motor wires soldered to it and they're enclosed, or they're already inside this heat shrink. You have two choices. Again, you cut the heat shrink, you peel the heat shrink, and you unsolder the motor wires, and then you solder your motor wires directly to the ESC, and then you get a big piece of heat shrink and you reshrink the ESC for a perfectly clean installation. Or if you're not comfortable doing that, then just don't worry about it. Cut the ESC wires that go to the motor, cut the motor wires, and then solder the wires in line together. That's the safest way to do it, because when you start going into those ESCs and you try to solder into those ESC tabs, you might burn something. You might overheat the ESC or burn a FET or burn a resistor or something like that. So, right now what I'm doing is I'm pre-tinning the motor wires. Make sure my tip is clean. Then I'm going to pre-tin the ESC. Just a little bit of solder. It really doesn't take that much. Just like that. Like that. Once that's pre-tin, then my next step is I solder the actual motor wires to the ESC. And this is quite uncomfortable the way I'm doing it, but it always helps to have somebody to help you do this. And if you feel like doing this before you install the motor on your frame, feel free to do so. The reason why I mount the motor on the frame first is simply because I can really get an accurate distance or measurement for how long my ESC wires need to be. My wires from the motor, my motor wires need to be. Otherwise, I don't have a good perspective on how long they need to be, and I can do them too long or too short, and then I'm in real trouble. So now I'm going to use these forceps right here. This will make my life way easier. Solder the second wire here. That's getting really hot, nice and hot. Perfect. So I'm checking my connections. They look super nice and clean. So that's it for that. So next up, I am going to go ahead and solder these two wires, positive and negative, to my power distribution board. Now keep in mind, as you look at the frame, you have two holes right here and you have two holes right here. These are for the standoffs that hold the top plate. These two are for the camera mount. So you have to leave enough slack to go around those. So I'll probably be like somewhere around there. So I'd rather have wires with a little bit of slack than wires that are just way too short. And as we put all the rest of this thing together, you will actually see how easy it is actually to mess up if you make your wires too short. You're probably always better to make your wires a little bit long and then have to like shorten them or resolder them later than you are to make them too short and then run out of wire, and then you're in some serious trouble at that point. So again, flux pen for these two. Then I'm going to go ahead and pre-tin these two, positive and negative. Right there. Right there. That's super easy. And then I'm going to look here. So you can see I have something that says VBAT, VBAT, and then GND. Obviously VBAT is the positive. I'm going to go like that and solder that real quick. And probably I should be using these because they'll help me a lot. And these connections are way easier to solder than what we did earlier with the Palalu and the board and all those. Those are a lot harder to solder. Of course, you need to be on the top of your game for soldering, but these are relatively easy because these wires are a little bit heavier gauge, and you know the tabs are bigger. All right, that looks pretty good. So as you can see here, we have our motor installed on the frame. We have our speed controller. We have the speed controller soldered to the board, and I still have enough room here for my camera mount. I have enough room here for my standoff. So what I'm doing next is I'm doing the same thing 3 more times. Doing the next motor and the next motor and the next motor. So let's go ahead and get that done, and we'll come back. Okay, so the next thing we're going to do here is we're going to go ahead and solder the main power wires. So like I showed before, you should have these wires handy. I already cut mine. Best way to cut them, what I do here, the best way to figure out the length. So if you look at your quad, once you're in this particular, I guess once you've installed it and you got into this point, you look at the wire and you put it in line to where you have to solder it on the board, and just basically measure to the end of the quad, like right about there. And that's about the right length to be able to install your XT60 in its proper location on the top plate, which we're going to get to that of course later, but that's about the right length right about there. It'll give you slack to where you can put the top plate, mount your XT60 connector to the top plate, and if you ever needed to remove the top plate for whatever reason, you have enough slack on the wire to set your top plate aside without having to remove the XT60 from its mount. So once you have the wires cut, next thing you do is you solder the wires to your XT60. So next I'm going to take some heat shrink, and I'm just going to make sure that I heat shrink that section there and shrink that. Done. And then I will proceed to solder this to the board. So you can see on the board where you have a GND for ground, and then you have your VBAT for the battery. So splice these wires once again. We'll do again a little bit of flux, and now this time around I will pre-tend these wires. So just put it on my helping hand and just add a little bit of solder there and make sure they're nice and tinned. Make sure they get really hot again. This is the most critical solder joint of the entire build, in my personal opinion, simply because you have the most amount of current flowing through here. You have 4 ESCs pulling on a lot of current while you're flying this stuff. Even if you're a beginner, trust me, you're going to see the most amount of current through this. So make sure that this is a solid solder joint from the XT60, from these wires to the XT60, and from these wires to your board. Holding with my fingers is not the best thing because it's getting really hot, but I feel like I have a much better grip. And again, not the cleanest, not the most beautiful solder joint, excuse me, but it's actually like really hot, which is exactly what I'm looking for. That's all that really matters, is to get these wires as hot as they can get. There we go. Really nice and hot solder joint. Okay, so the next thing you do once you get to this point is, this is the part we discussed in the beginning of the video where I recommended that you would have a multimeter. Once again, not a strict requirement, but very well recommended, because at this point, if you have a multimeter, you can check for continuity. So when you solder, if you make a mistake and you overlap 2 taps, and you create a short, you go ahead and you plug your battery into your quad, you're going to burn stuff up. You're going to see smoke, you're going to destroy everything. So it's always good to check for continuity if you have a way to do so. Again, you can buy a multimeter from any hardware store. Most of them are pretty inexpensive. So on this one right here, we have it set for continuity. So if these 2 touches, you can see here, you can see the continuity, and otherwise you see that there's no continuity there. So what I do is just pick a ground, because they're all common. So I'll pick my main ground here, and then I'll start going through all the positive connections here. So that's a positive, as you can see, no continuity. That's a positive on an ESC, no continuity. Another positive, nothing. This main positive, nothing. This positive, nothing. Positive, nothing. Positive, nothing. So that means nothing is shorted, so it's safe to plug this thing in. So next up, I'm going to set this to voltage, and I'm going to make sure it's working. So I'm going to use my battery. I have a 3-cell LiPo here. I'm going to make sure this is reading voltage, and as you can see, is reading 12.58. So it's almost fully charged. So now I can plug my battery without being worried that things are going to blow up. You still cross your fingers, everything is good. And then I'm just going to go over checking voltage. You don't really need to do this, but I just like to do it. So I have the same 12.58. And then the next thing I'm going to do is, because I really don't remember, to be honest with you, which voltage regulator, which BLHeli is the 5 volt and which one is the 9 volt for my video transmitter, I'm just going to check the output here. So I'm going to check this side. You got to be really careful not to short anything. So you can see there, this is a 5 reverse polarity, but that doesn't matter here as long as they don't touch. This is the 5 volt BLHeli on this side. Left side is 5 volts, and this should be 9. So you can see 0892. That's close enough. So the right side of the quad is looking from behind. It's a 9 volt. The left side is looking from behind. Is the 5 volt. So with that being done, this side, which is 5 volt, the left side, I need to go ahead and solder the servo extension, or the servo end that I talked about earlier. And what this does is it's going to power your board. So this will get plugged into your board and will supply the board with 5 volts. So I'm going to solder it on this side because, again, this is the 5 volt side. So basically, you go to a hobby shop, buy a servo extension, get rid of the signal wire because you really don't need a signal wire. You only need positive, negative. This is the JR style, which has the red and brown and I believe orange wires. You can get a Futaba style, which is red, black, and white or whatever. No big deal. Just make sure you have your positive, negative. And then always solder it from the inside so that when you solder, you can run this on the inside of your frame. If you solder on the outside, you're going to have wires sticking out of the side of the frame, which you don't want that to happen. So I already pre-tinned these wires. I cut them and splice them and tin them up. So they're all good to be soldered. Okay, it's all said and done. Doesn't look very clean, but it'll work. So now this wire can be run in this fashion, and the board will be like so, and the wire will just plug into the board. Then you'll look at your video transmitter, and it'll come with a harness. And the harness basically has one side that goes to your camera, and the other side that goes to your power distribution board that supplies the power to the video transmitter itself. I already cut this to length. I already spliced it. I already pre-tinned it. But the best way to do that, just to give you a quick explanation, is you lay your video transmitter on your frame, and then you connect your harness or your connector there to your video transmitter, and you basically kind of eyeball the length there, and we know these are going here. As you can see, I left quite a bit of slack on this wire. It's better to have slack than to be missing wire. You just cut it, remove it from the video transmitter, and then go ahead and solder it. And again, soldering from the inside. And this is really, really thin gauge, so just be careful with the soldering. It shouldn't take much heat, and it shouldn't take much time, and that wire should be soldered very easily there. Done. And this wire will eventually go back, plug into the video transmitter. This will go over the top and plug into the camera, and we'll talk about that camera setup here in a minute. Okay, up next we're going to go ahead and install the board. So, pretty simple task. So your kit came, or your frame came with the different kinds of spacers. So You can use these in any way, shape, or form you prefer, depending on the height of your board, your PDB, your power distribution board, and the height of your actual flight control board and so forth. I'm going to use 2 spacers on each one of these long bolts, and that should give me enough space, enough room to be able to fit my power distribution board. So it's 2, 2, 2, and 2, and then I got to make sure that, for example, this, which is for my VTX, my video transmitter, is moved to the back. This is to power my board. It's also moved to the back. And when you install the board, make sure you're going in the right orientation, even though you can change this later in the program. You want to actually do this correctly. This board, it's hard to say, it's hard to tell on video, to see on the video, but it's got an arrow pointing that way, meaning forward. So we're going to go in like this. And it's got to be like really careful and try to put it in like slowly. And it should sit flush with those spacers. And again, your kit came with a total of 8 spacers, so you can use 4 and 4 right there. If your stack here is different because your power distribution board is taller or shorter or whatever, you can get some of these spacers very easily online. Everybody has a different requirement. So okay, that's it for the board. And then I'm going to take the nylon nuts and I'm going to put them here. And as you can see, the bolts supplied here, these long bolts are actually really long. As you can see, you have plenty of bolt left. The purpose for that is like if you have, again, a power distribution board that is like taller than usual because you decided to go aftermarket with your PDB, your power distribution board, or if your flight control board is taller or whatever, you need more real estate, say, for example, at the very bottom here to install a separate regulator or something else, then you have plenty of room here to raise this up and make more room for electronics or whatever, regulators or whatever it is that you need. So I'll go ahead and tighten these later off camera, but that's it for now. And then we're going to go ahead and install the camera. So the camera is actually not very difficult to work on. Just get the actual camera itself. You're going to need your camera and you're going to need the harness that comes with the camera. And the harness looks like this. And as you can see, this wire has a connector that is already made that can plug into that. I personally don't like to do this because look at how long this wire is. It's extremely long, so I'm gonna have to coil this up. I just like to cut this and then cut this and then solder it together so it's made to length and it's nice and neat, and we'll get to that here in a minute. But you're gonna need your camera harness and the camera itself. You do not need anything else that comes with the cameras. Most of these cameras come with camera mounts and things like that. You're not going to need any of that. You just need the camera itself and the harness. One thing that you're going to need that I unfortunately forgot to mention in the beginning of the video is a very small Phillips screwdriver. In the interim, let's open the little bag that has the complete camera assembly that came with the kit. And this is something that might not come exactly packaged in the way you see it. When you get your kit, it might be packaged slightly different, but I just had it all prepared like this. So you're gonna have 2 bolts right here that hold the carbon plate to the top of the camera mount. You're going to have the bottom of the camera mount, a long bolt with 2 washers, and let's see what else here. And you got these 2 little bolts that are long and a nylon nut. You get the small Phillips screwdriver and you remove the 2 Phillips screws from the back of the camera. Might need to remove that little sticker, and the whole back plate of the camera will fall out of the camera, so you got to be careful. The whole camera fell apart. No big deal. We'll just put it back together. with the back plate. So basically all we did was just to remove the 2 Phillips screws from there, and we're going to replace them with the one that come with the kit. So we're going to take this back plate, and if you look at this back plate, you have a recessed area on this side, and that's where these bolts are going to go in. So you're going to go ahead and put those bolts in, and again, I personally like to use some Loctite, and I'm going to Loctite the bolts, and I'm going to tighten this plate to this aluminum upper, I guess you could call it the upper part of the camera mount assembly. So I'll just put one at a time. So there's 2 bolts right here, and then I'm going to tighten them the best I can. Go as tight as I can on those. Perfect. Once that is done, then I'm going to mount this to the camera, and we take these tiny little bolts, these are 2mm, and we're just basically going to run them through here and tighten the camera itself onto this piece of carbon fiber. And be careful, because you're screwing these on the plastic, and you can strip the plastic if you go way too tight. Just get a feel for it. You want them really tight, sort of snug, but you don't want to over tighten them to where you strip them, because then your camera is not going to be as tight as it can be onto this carbon fiber plate. So that's it for that. And one thing that's important here is I'm going to solder this harness from the camera to the video transmitter. So I'm going to mount it on the camera, and I'm going to position the camera roughly where it belongs on the quad, and I'm going to position the video transmitter roughly where it goes on the quad, and I'm going to connect the video transmitter harness to the video transmitter, and I'm going to kind of get a good idea as to how long I need to make this wire. So if the video transmitter goes here, and the video transmitter wire comes this way, and the camera goes here, and the wire comes this way, so I would say that if I caught these 2 wires right at about this location, it should be perfect. I should have decent amount of slack. So I'm going to cut this one right here. Get out of the way. I'm going to cut this one right here. And again, you don't have to do this, but I just like to do this simply because I don't like a lot of clutter of wires. So I'm going to solder now these wires together, and we'll just resume after that. Okay, as you guys can see here, I already have this soldered. Basically shortened the wires. That was the whole purpose of soldering this. You don't have to do this, but it just looks a lot cleaner than having the coil wires everywhere. So it's just a much nicer, much cleaner setup. So the next step is to install the camera. So first thing you have got to determine is whether you have a top connector camera or a bottom connector camera. If you have a top connector camera, the camera obviously has to be placed on the quad in this fashion. If you had a bottom connector camera, then you would mount the camera like this. That's very important because that's going to determine your actual video. If you have a top connector camera and you mount it upside down, now your image is going to be reversed. So make sure that you know whether you have a top or a bottom connector camera. And once you make that determination, I know this is a top connector camera. So what I'm going to do here is I'm going to mount this other part, the lower, I guess you could call this the lower CNC part of the camera, FPV camera assembly, in this fashion. If I had a bottom connector camera, I would be mounting it like this. But since I have a top connector camera, I'm going to mount it like this. And as you can see here, we have a slot, and the whole point of the slot is so that you can adjust your angle. So if you want a very shallow angle on your camera, so basically pointing straight out, you would mount the camera like this. If you want a higher angle for faster flying, you would move the camera down on the slot and point it up like so. So I'm going to put it somewhere in the middle of this slot for the time being. So for that, what we're going to need is the lone bolt. I believe is a 325, 3x25 bolt. Comes with the kit. And you're going to need your 2 washers. And you're going to need your nylon nut. So we're going to go ahead and put one of the washers through the bolt, or bolt through the washer. Go like this. Then put the other washer on the other side. And then put the nylon nut. And at this point, I'm not going to over tighten this. I'm just going to snug it. And I want to be able to still rotate this because I'm going to adjust my final angle before FPV flight at the last minute. But I want it to where there's some resistance, but it's yet easy to move with my hands. So I'm going to take the number 2 driver here, and I'm going to take my 5.5 wrench. And as I explained in the beginning of the video, you could use pliers for this. You really don't need a 5.5 millimeter wrench. I just choose to use the proper wrench so I don't booger up the nut. So as you can see here, the camera is loose within the slot, but it's good enough for now just to install under the quad. In fact, I probably should snug that bolt just a little bit more, just a hair, right about there. So perfect. So now I'm going to mount this onto the quad. First I'm going to plug it in, just because it's easier, and I'm going to mount it like so. And for that we're going to need 2 more screws. These are 3x6s, and I'm going to use a little bit of Loctite. And if you look at the bottom of the frame, you basically have 1 hole, I guess you could say, in 1 slot. And the reason for that is you can adjust the angle of the camera side to side. So due to very minor tolerance issues during production, we chose to have 1 hole and 1 slot, so that if the 2 holes are not absolutely perfectly symmetrical, you can make any small corrections to the camera angle, the side to side camera angle. I'm going to show you that here in a second. I'm going to get the bolts in there tight, just barely in there. And as you can see, because of the slot, I can move the camera left to right. So I'm going to try to eyeball it and get it as close as I possibly can. I might need to make some final adjustments later before FPV flight. But once I get it to where I feel like it's where it needs to be, then I can crank on these bolts. And I think I'm pretty good there. So I'm going to crank on these 2 bolts right here. And that does it. And again, as you can see, the camera is pretty loose up and down. And of course I need to tighten this lone bolt with this nut, but I will not do that until last minute, right before FPV flight. So as you can see, this is all done. Next step is I'm going to take my VTX, my video transmitter. I'm going to plug it into here, and that's it. Up next, I'm going to go ahead and put a little bit of double-sided tape on this side of the video transmitter and tape it to the frame. And if you pay attention here, you have these slots for zip ties. So you don't want those slots to run over the button on the VTX, because then you can't push the button to switch channels. So I'll find a good spot. You want this to be relatively, I guess you could say, far into the frame, because you don't want to expose this connector, this SMA connector, past the frame. Otherwise, if you have a hard crash, you're going to break this SMA connector out of the VTX. So you want this kind of far in to where when you zip tie on this side, you're zip tying the antenna connector and not necessarily the VTX connector on its own. But at the same time, you have got to watch for this button as it lines up with these two slots. So if you look at it, right about there would be a perfect mounting location. So I'm going to go ahead and do that now, and then double side tape that, and then I'll also double side tape my ESCs, and then we'll resume. Okay, so as you guys can see here, I have put double-sided tape on all the ESCs, all 4 ESCs, and I have put double-sided tape on the VTX, the video transmitter, and it's mounted on its proper location here. I've connected the harness to it, so everything seems to be in place at this point. Almost ready, actually. So next step, very important. If you plug in a battery at this moment, make sure that you put an antenna on your video transmitter. So I'm going to go ahead and put the antenna. This is very important for all of you that are not aware of this. The video transmitter will blow up, will actually burn if you power it up for a sustained period of time without an antenna installed. So make sure you put the antenna on your video transmitter before you apply power. I'm not going to apply power at this moment since I really don't need to do that right at this very moment. But I always make sure that once my video transmitter is installed on the quad and is connected to the power source, that I have the antenna just in case if I ever forget and I plug it in, then I don't blow it up. So at this point we just need to adjust the connections, work on the connections here. So if you look at the quad from the back, number 1, number 2, number 3, and number 4. Again, 1, 2, 3, 4. So if you look closely at your board, it's really hard to tell on camera and you can't see it at this point, but the board, the flight control board right here, the other side of the flight control board shows the pin numbers. These boards are made not just for quads, but they're also made for hex copters and so forth, so they can accept typically more than 4 motors. You're going to make sure that you're using ports 1 through 4. And this board is labeled port 1 on this side right here. So ESC number 1, which we have right here, will go to port number 1. And ESC number 2, which is right here, will of course go to port 2. And this will be motor 3. This will go to, of course, port 3, which is right here. And on this board, the negative is at the top of these pins. So once these are plugged in and in their respective locations, the next step of what I'm going to do here is I'm going to mount my standoffs. So in the frame kit, there's 8 different standoffs. 4 short ones and 4 long ones. So I'm going to separate them here. As you can see, these are the long ones right here, and these are the short ones right here. And as you look at your frame right here, you can kind of put a spacer and eyeball to see if you have room for the short spacer. Basically, the short spacer allows the stop plate to be closer to the bottom plate. If you solder the pins on the board going up, like I explained earlier, then you might need the longer spacers as you will need more clearance here. I believe, even though I have a receiver to mount back here, that I will have room with the short spacers. And I'm going to double check real quick, just kind of eyeballing it and see. Yeah, looks like I will have just enough room. It won't be plenty of room to spare, but I'll have enough room. So get the remaining, you should have 8 screws remaining, 8 bolts remaining in your frame box or kit. And once again, I'm going to use some Loctite and I'm going to mount the spacers. And the spacers are going to go right here. We got 1, 2, 3, and 4. And the last spacer, number 4. Now these spacers have little holes which allow you to stick some kind of tool just to hold them in place so that you can tighten them before you install them on both sides. So I'm just going to make sure they're tight here. That's pretty tight. And that's it. All spacers are now installed and ready. Now the next step is I have to fix this clutter of wires, of course, and I will do that with some zip ties. Then we have this wire right here, which was our power wire for the board. So we can plug that in any port on the board. I'm plugging it on the last port right here. Just like that. And we have this wire which is going to go to our receiver. So that's coming last. So now what I'm going to do is I'm going to organize these wires just a little bit and try to make the whole thing a little bit less messy. So up next, I'm going to go ahead and install my receiver. And I'm going to be, again, as I said before, using the Jetta receiver. Again, any receiver that depends on your particular radio will work. I'm going to put it right in this location. And to protect the antennas, I'm going to loop them around and perhaps use tape or something to just hold them in place. That's a matter of personal preference. Whatever, in whichever shape or form that you would prefer to install the receiver, you can go for it. So I'm going to go ahead and install the receiver, and I'm going to plug my main wire that we talked about before to the receiver itself. Okay, so as you can see here, I just finished installing my receiver. I also made a couple of changes here. I cleaned up my wires, just made it overall nice and neat. And then if the camera can capture this, I mounted my receiver with double-sided tape, and then I have these antennas. I just basically use some electrical tape to hold the antennas here. That's about it. I'm going to go ahead and plug it in right there. Perfect. And tuck that wire, and then I just need to tighten these up. So 4 screws here. Okay, now last but not least, I would say the most important part of the build, not really, but one of the coolest parts of the build is the XT60 mount. So basically you have your mount here and you have the 4 screws, and the goal is for this to basically go like that, and you will feel it as it gets captured in there. You just got to find the right side. There it is right there. So one of the beauties of this XT60 CNC aluminum mount is the fact that for all of you guys that are familiar with XT60 connectors, they're really nice, but over time they start to loosen up. And so what you do in this particular situation is you tighten these bolts a little bit more, and that compresses the connector itself, allowing you to use the connector to extend, I guess you could say, the lifetime of the connector. Generally, a lot of people, when they notice that their connector starts to get a little bit too loose on the battery, what they do is they take a tiny little X-Acto knife, or perhaps they take a tiny little screwdriver, and they basically open the pins inside the connector to stretch them out a little bit to make the connector tight again. Well, with this setup right here, all you have to do is tighten up these 4 bolts. So you can go as tight as you want or as loose as you want. I start loose, and then as the connector starts to wear, I start tightening these just a little bit. And nice thing about that is if you have a hard crash, your battery can eject or come out of the quad, but it'll stay connected. So that actually helps because it allows your motors to beep, and of course you can hear the motors and locate your quad. So that's it for that. Then we have some couple of really minor last minute adjustments here. We have to adjust the camera angle. What you do is you move the slot on the camera, you move the camera all the way down on the slot, all the way up on the slot, and that allows you to run a straight camera angle. If you want the camera angle to be really high, then you move the camera down on that slot, and then that allows you, of course, to have a very steep camera angle. I generally fly, I really don't know, I believe it's about 50 degrees or whatever, so right about there. So I'm not going to crank on those camera bolts just yet. That's the very last thing I do, because once I'm ready to fly FPV, then I'll just put my goggles on, I'll fine tune the camera angle to my choice, and then I'll tighten the camera. But that's it for that. That's all we have going on here for the build, folks. It's pretty much done. So what I will do here is I will take some zip ties, and I'm going to put 4 zip ties, 1 on each ESC, and 2 zip ties around the video transmitter. So this is the reason as to why when we designed this we put these little indents on the frame, is so that you could mount zip ties, and so that they wouldn't come off during a crash, or they wouldn't move around or slide around. Alright, let's move on to the configuration section and setting up the speed controllers. Okay, so the next step is to configure your speed controllers and set up your flight control board. Basically, the first thing you want to do is you want to download a piece of software called Cleanflight Configurator, provided that your board comes with Cleanflight pre-installed. And this is a very complex topic. We can spend 5 hours talking about this. I'm going to make it as quick and easy as I can possibly make it. But I recommend that you watch our other videos about flashing your board and the various versions of Cleanflight that you can run. I personally run something called BetaFlight. It's put out by, it's open source, put out by a guy named Boris. If you search for Boris B BetaFlight downloads on Google, you will find it. You can download the firmware from there, and you can flash your board using the same Cleanflight configurator that you see here on the screen. But more than likely your board will come pre-configured with some sort of Cleanflight version. And Cleanflight is, again, open source, relatively easy to use, not very complicated. What's difficult is finding the right version and things like that. And it's really hard to recommend a version because the versions change. I'm not exaggerating, but literally once a week there's a new version out on the website. And generally I run 2 or 3 versions behind to ensure that I'm running a stable version. And again, we're putting out a video in the future, maybe it might be available as a time at this time that will explain how to flash your board and so forth. But for the time being, let's just make sure that you have Cleanflight, provided again your board has Cleanflight pre-installed. Most of them do, so it shouldn't be an issue. Download Cleanflight Configurator. You can see the screen for the URL as to where to download this piece of software. And then once you download it, you connect a micro USB cord to your computer, and then you plug it into your board. And once that's done, you're going to see that your laptop has made a connection to it. And once that happens, you click the connect button here, and then you get a graphical interface of your quad. That's the first screen. It's the setup screen. On the left hand side, you can see the various screens that you can access. We're not going to go over all of them because you really don't need to use them all. You need to use just a few. Before we get into any of this, the purpose as to why we came here first is to go to the motors tab. You will see a tab that says motors. And then what we're going to do here is we're going to plug our battery to the quad to give power to the ESCs. Obviously at this point, make sure your props are not installed. This is why I purposely didn't install the props in the previous step here while we were finishing the build. And once the battery's connected to the quad and the ESCs boot up, once again go to the motors tab and select this checkbox here. It says motor test mode, and obviously it gives you a notice. Make sure you don't have props, you understand the risks and everything else. What this does is that this gives full control to the motors. It gives the computer full control to the motors, so you don't have to use your transmitter to control the motors. You control them through the computer. As you can see here, you have your quad, you have your motors, 1, 2, 3, 4. And what we're going to do here is we're going to move this slider up and down a little bit just to get the motors to spool up. And then by doing that, we're going to ensure 2 things. Number 1, that we plug the motors correctly. As I explained before, if you look at the quad from behind, motor number 1 is rear right, motor number 2 is front right, motor number 3 is rear left, motor number 4 is front left. So we're going to make sure the motors are correctly connected to your board in the proper order, and we're also going to check for motor direction. And there's a little graphic that you can see here to where it shows you in which direction these motors should be running. So if you think about it, all motors need to kind of turn inwards into the quad. So it's actually quite simple. So as you can see here, motor number 1 should be rotating clockwise. So Motor number 1 is right here, rear right. I'm going to move the slider up and down just to determine that I have the right motor in the right port and that I have the right direction. Okay, so it's the correct motor. Number 1 is here, but I don't know if the video can capture it. It's reversed. So it's spinning backwards. I got to fix that. And again, that's why we're here, just to determine our motor direction. Motor number 2, so I'll make a quick note here, and I'll put that 1 needs to be reversed. Then motor number 2, it's the correct motor, and it should be spinning counterclockwise based on this. And it is spinning the right way, so I don't need to change that. Motor number 3, again, correct motor, which is rear left, and it should be spinning, as you can see on this graphic here, counterclockwise. And it is spinning counterclockwise, so we're good on that. And motor number 4 is spinning counterclockwise, so it needs to be reversed. As you can see here, it should spin clockwise. Yep, I just confirmed this is incorrect, so I'll make a note, motor number 4. So after that's done, we're going to go ahead and go to a different program and set up our ESCs. Okay, this next program is called BLHeli Suite. And once again, look at your screen for the URL as to where to download it. You can just simply search on Google, BLHeli Suite, download. You will find it very popular. Most ESCs are running BLHeli. So you open BLHeli, and the first thing you do is you make sure that you select the type of ESC bootloader that you have. So if you're using these DYSs, you're going to select here where it says select Atmel or Scilabs interface, and we're going to do Scilabs BLHeli bootloader Cleanflight. And this is because we're using Cleanflight for this purpose. So go in here, and then once this is done, you click connect. And as you can see, I already connected, and it says multiple ESCs. After I do that, I plug in my battery again. And then I simply push where it says check. And now it's going to check all the ESCs. And right here it's telling me that I have DYS XM20A, XM20A. It's actually XM30, so I'm assuming that it's reading the wrong configuration. Sometimes it happens. It's open source software. Even though it's awesome and it has a lot of possibilities, there's some bugs here and there. So I'm not going to worry about that for now. So I'm reading the revision here. It says that I'm running revision 14.4. The latest as of this video is 14.6. I am not going to update it. I always like to run a couple of versions behind. If you wanted to flash it and update the firmware, it's super easy to do. You push this button where it says flash BLHeli, and then you simply pick the revision you want. So for this one, the latest available is 14.6, but I'm not going to do that. I'm just gonna leave that revision. So the next step is to configure the ESCs. So where you see here it says multiple ESCs, and right now master is selected. So what I'm going to do is I'm going to unselect them all and only leave one checked, and I'm going to click on read setup. It says read successfully. Okay, a few things I change here, and you have to do this for all your ESCs. I usually turn temperature protection off. I change, of course, look at the motor direction. I made in my notes that number 1 needs to be reversed, so I'll reverse that. One thing that you have to do here is change the PWM frequency damp to damp light if it's not already checked. On this speed controller it is checked, so that's perfect. The other thing that I like to do here is the beep strength, the beacon strength. That is how loud the motor will beep after a predetermined amount of time. So for example, if you crash, the motors will start beeping after a certain amount of time, and this determines how loud they will beep. I go to about 128 always. Try not to go too high, because if you do, I've heard stories that motors can actually burn up because your ESCs are using your motors to create noise. So you need a decent amount of volume so that you can hear it, if it's lost and you can find it after a crash, but you don't want it too loud or you can hurt the motor. Beacon delay, I set it down to 2, and that's how long it takes after a period of inactivity before the ESCs start to send that signal to the motor and they start to beep. After I make those changes, I click on Write Setup. It says Write OK, so I'm done with that. Then I unselect 1 and select 2. Click on Read Setup, says OK, and then I make the same changes. Temperature protection off. On this one, I already have damp light. I'm not going to change the motor direction on 2 because that was correct. Then beacon strength all the way up to 128, and again, this beacon strength is a matter of personal preference. So it's going to go to 128, and then the delay 2 minutes, and then Write Setup, okay, and then I'll repeat that for number 3. Write Setup. Perfect. And then last but not least, number 4. And I remember I have to reverse number 4. So I just did. Temperature protection off. Beacon delay 2. Beacon strength 128. And then Write Setup. It says written OK, so that's all set. So the next step to do here is you close BLHeli, you unplug your quad. BLHeli will probably crash when it closes because it's Windows. There we go. Crash, no problem. Then I will go back to Cleanflight, and now I'm going to double check the motor directions one more time. So same procedure, I understand the risks. I plug it in. So motor number 1 should be clockwise. And it is. Motor number 2 should be counterclockwise. And it is. Number 3 counterclockwise. And it is. Number 4 clockwise. And it is. So we're all good with that. That's awesome. So up next, we're basically going to set up your flight controller, making sure everything's moving in the right direction, making sure your transmitter is working and everything else. Okay, so now we're back at the Cleanflight configurator. We're going to go ahead and connect. And the first screen you see here is a graphical interface of your actual quad. And you can do a lot of different things here, but the most important purpose of this screen is to see that your orientation is correct. So as you move your quad up and down and left and right, you will see this graphic here showing, and you want to make sure that that matches. If that does not match, you need to go and change the orientation of the board within the software here. If you push on reset z-axis, basically centers the quad so that you're actually looking at the tail in this graphical interface. So that's pretty cool. Mine is fine. I already made a couple of adjustments, and I'll show you that here in a minute. But basically, if you go to ports, which is the second option here, you can also see that I enabled the serial RX under UART3. And if you remember, when we were soldering the board, I made a comment and I said that I'm using UART3 connection to the board because I had a Jetty transmitter and I was using UDI. So because I'm using UART3, I enabled the serial RX. There's many different options to connect the board, and again, we recommend that you watch the video about how to solder the board because there's many different options. You have, again, the UDI method, which is serial RX and is same as SBus, but you also have PPM, which is widely used. You have Spectrum, which is also widely used. So we'll get into detail on that other video about that, but for now I have serial RX here. Up next, I have configuration tab. Here's simple, just look at the top of quad. This is an X, so quad X is perfect. ESC motor features, motor stop, and when I enable that, that basically stopped the motors. When I initialized, it doesn't let the motors run at an idle when I'm actually armed. I don't like the motors running at an idle when I'm armed, so I'm turning that off. One shot is enabled. To not get too technical, that basically increases or speeds up communication between your board and your ESCs. Disarm motors regardless of throttle value, all that is fine. Don't need to touch anything. What we do need to touch is the minimum throttle. We need to initially set it at about 1,000, and then the maximum throttle here, initially we should set it at 2,000. Aside from that, minimum command, this is a personal preference. I run it low at about 960. Then you have your board and sensor alignment, and this is what I was talking about earlier. When you go back up to the setup screen and you see this graphical interface, if something is wrong there, if the quad is not moving the way it's supposed to be moving, then you should go ahead and make an adjustment here. Generally, you need to adjust your yaw. The yaw is the axis that usually gets a little screwed up. And as you can see here, because I moved away from the screen, I lost these settings. So I'm going to make that again, minimum throttle 1,000, maximum throttle 2,000. 1,000, 2,000, and I drop my minimum command to 960, and I have motor stop on. Okay, so this is all corrected. Once again, if your quad is not moving in the same orientation, you need to play with the yaw axis. So you can change it say 90 degrees or 180 degrees or whatever it takes. Then here, my receiver mode is serial. For the most part, the default will be PPM, but I'm running serial, so I already adjusted that. Battery voltage, it wants to monitor battery voltage. I'm not monitoring battery voltage, so that's off. Let's see here, and then the serial receiver provider. Here's where you can select if you have Spectrum or Spectrum 2048, or you have S-Bus or X-Bus. I'm running X-Bus mode B because that's what Jetty uses. And that's about it for the screen. Before I move out of the screen, I'm going to click Save and Reboot. And the board will reboot and reconnect. And I'm going to go back here and make sure the options are saved. Generally, I move from one screen to the next and come back here and make sure everything's fine. So, perfect. Next screen is failsafe. I generally leave it alone at default settings. It works really well. No need to mess with this. Next is PID tuning. This is, again, a matter of personal preference. I like to run multi-we rewrite. So that's actually like a nice PID controller. No need to mess with it. You can, for the most part, leave all your PIDs intact. Roll rate, pitch rate, all that. That's just a matter of feel. Obviously, the roll rate changes how fast the quad rolls. Pitch changes how fast it pitches up and down, meaning elevator axis back and forth on your stick. Yaw is, of course, what I would call rudder on a helicopter. And then you have a TPA, which generally I like to make 0. That basically changes the control loop at higher throttle. So this is all good with me. I'm just going to click Save. And it should be rebooting. Sometimes it doesn't, but I disconnect and I reconnect. And I go there and make sure that whatever I changed took place, and it did. Next up, we go to receiver. So for receiver, what I do is I turn on my transmitter, which I have here next to me, and I plug the battery into the quad. And as you can see here, what you're looking for in this particular screen is you can see all these graphics. You want to make sure that when you move your sticks, these are moving. So if I move my aileron or my roll, this should move right and left. My elevator should move back this way and up and forward this way. So back elevator, forward elevator, my yaw left and right, and my throttle up and down. And then you want these three values, roll, pitch, and yaw, to be as close to 1500 as you possibly can. So what I do with that is I just go into my transmitter endpoint correction sub-trim, and I go to sub-trim, for example, for aileron, which is roll, and that's the closest I can get, 1498 or 1501. I'm going to leave it at 1501. Then I'll do the same for elevator, and that's 1500. That's pretty close. I'll leave it there. Then I'll do rudder, 1501. Perfect. Then I make sure that left and right, so if I move left, it goes to 1020, right 1980. I want to stay within that range, so I'm happy with that. 1976, 1023, on that one is 1022, 1976, and this is 1023, 1981. I'm going to reduce that rudder a little bit so it's below the 1976. That's better. Then for throttle, I want to make sure my low throttle is at about 1020. My high throttle is about 1980. So that's about good right there. And that's it. Here you have your throttle midpoint. I don't like to mess with that. Here you have your throttle expo. We don't need to mess with that. If you feel that your throttle is too touchy, you can adjust that, but really there's not much need for that. The RC dead band, no need to mess with it. Same with the yaw dead band. And then the RC rate, 1.0. That's relatively fast for most people, most beginners. You can drop that down to 0.50, and that would be a good start. Same with RC Expo, that's 0.6. That's actually pretty good. No need to change that, so we're good with that one. Let's see what else we got here. That's about it. That's important for the screen, really. I don't think I made any changes there, but I'm clicking save anyway. Then modes. So we can get into this later as we are going to do a more in-depth video about Cleanflight and how to configure things. But for now, you don't need to worry about that. This is where you assign, for example, self-leveling mode and arm disarm to certain switches and things like that. If you want to run self-leveling mode, then what you would do is you would enable it here. You would go to angle, and then you can disregard any of this. You can assign it to a switch, for example, aux1 on your transmitter, and you can select a range to where when you go in one position of the switch, it goes one way, and another position goes the other way. But if you want angle for the entire flight envelope, you just go like this and you click save, and that means it's going to self-level itself. I personally don't like that, don't run it, so I'm not going to enable it. So that's it for modes. So to arm, if you don't select a certain switch for arming here, to arm you would just use right rudder, and that would arm the motors, and left rudder would disarm the motors. Up next we have adjustments. We're not going to mess with this. Servos, GPS, no need to worry about it, and then we arrive at motors. So here we're going to do what we did before once again. We're going to go ahead and motor test. We're going to go to full throttle. We're going to plug in. You're going to hear these tones. When they're done, you go all the way down on the slider. And that basically teaches your motors what your speed controllers, what's the maximum throttle, what's the minimum throttle. Once you're done with that, you plug back in. And once they initialize, the goal here is to move the slider to see where the motors start to spool up. It's very difficult for me with this particular tablet because I don't have a keyboard that I can use with up and down arrows. Ideally, if you had up and down arrows, you could find that spot better, but I have to move up and down. As you can see here at 1064, motors are still not up. Let me see if I can be very careful. 1075 is running. 1064. I'm just going to go to 1060 for my low throttle. I'm going to write it down, 1060, just to be safe. And then we're going to do the same for full throttle. So I go to full throttle and I start backing down on the slider until I hear a pitch change on the motor. And that's where I'm going to set my high throttle at. So let's see, full throttle. No change between about 1955. 1955 should be a good value for my high throttle. So once that's done, I go back to the very beginning under configuration, and now I changed my minimum throttle to 1060, my maximum throttle to 1955. Click save and reboot. And that's it. To be honest with you, this is really all that's essential for flight. Okay, so this concludes the build on the sRacer 207 or 207. And now the last thing we need to do before we go fly this thing is to put the props on the quad. So you remember when we were talking about motors and setting up the speed controllers and plugging in the speed controllers to the flight control board, I was explaining which motor goes where. So if you look at the quad from the back, as if you're riding on it, motor number 1 is rear right, motor number 2 is front right, motor number 3 is rear left, motor number 4 is front left. So basically motor number 1 and motor number 4 will use the same type of prop, meaning the prop will have the same pitch. Motor number 2 and motor number 3 will also use the same prop, but the props on motor number 1 and 4 and motor number 2 or 3 are different, meaning motor number 1 and 4 will take a prop, a reversed pitch prop. And once you're accustomed to using these props and installing them on your quad, you're immediately going to know the pitch on the prop, and you're going to know just by looking at the prop if it's a reversed or a regular or forward, I guess you could say, prop. But if you're not familiar with the pitch, most props actually have, they're labeled, and as you can see here, I don't know if the camera can capture this, but this one says 5045R. R stands for reverse. And 50 means it's a 5-inch prop, 45 means the amount of pitch the prop has, and then the R means is reversed. So the reverse props will go on motor number 1 and motor number 4, and the forward props will go on motor number 2 and motor number 3. Another way to look at the props to make sure that they're forward or reverse is all reverse props. If you look at the prop from behind, the pitch on the prop goes counterclockwise. If you look at a forward prop, the pitch on the prop goes clockwise. So again, this is a reverse prop. I'm going to put it on motor number 1, and I'm going to put it on motor number 4. So you can see these two props are the same. Then I'm going to take a forward prop and I'm going to put it on motor number 2 and motor number 3. And that's about it. One thing that is really important is make sure, once again, that the props are placed properly. I have personally put the props wrong before, and I'm actually, I've been doing FPV for a relatively long period of time, and I still make an occasional mistake simply because you're talking to friends or you're in the middle of something else, you're thinking about something else, and you install the props and you put one prop wrong, and that could potentially lead to an injury. So be very careful if you're trying to take off and you have the wrong prop installed, or props are mixed up and they're not installed correctly. The quad can literally do a flip and come towards you. And even though these things are not as dangerous as an RC helicopter, they can still do a lot of damage. So be very careful with that. So here we go, props are installed. So what I'm going to do, and I'm not going to show this on video, but I'm going to go outside now and I'm going to do a line of sight flight. I consider myself a decent pilot at line of sight. The reason why I want to do line of sight is because I want to pick this up into a hover, and I want to make sure that this is hovering correctly, throttle's working right, you know, everything moves correct in the right direction and feels good to me. After that, I'm going to hook up my receiver and my goggles, make sure I have clear video, and only then I'm going to proceed to do a FPV flight. So I hope you guys enjoyed this video. I apologize if I gave you way too much information, and I also apologize if I didn't give you enough information. These things are quite complex. It takes a lot of learning to set them up. There's a lot of stuff coming out to the market. They're changing very, very quickly, so by the time you watch this video, all these electronics might be obsolete or outdated, but for all practical purposes, the setup functionality, or the way in which we run the setups and the builds, will hopefully remain the same for a long time. So with all this being said, thank you so much for watching, and this was fun to do this video, so I hope this was helpful in teaching you how to build your sRacer 207.